Hello and welcome to session 2. In this session we're going to look at the version of Ubuntu we use, and then we're going to go through the installation process. General discussion about the deployment mechanism normally used in actual hardware deployments, and then what we'll do is we're going to look at VMware, how we configure VMware to support our operating system, and then we'll go through the Ubuntu installation. After that, post-installation, we'll look at how we update the operating system, install essential packages, and do some troubleshooting. First of all, which version are we going to use? Well, Ubuntu was released in several versions. The long-term support versions have 5 years worth of support from Canonical. So in this module, we'll be using 2004 long-term support. When it comes to deploying Linux servers, invariably they're deployed as headless machines in a controlled server room. By headless, we mean there's no monitor or keyboard. So basically the only access you can gain to that machine is remotely. Generally speaking, the remote software that we use for this is SSH. It's pretty much the most secure environment we've got at the moment. We've got 2 ways of getting into the server using SSH. One of them is to use PuTTY, which is available on Windows and Linux. And the other one is to use SSH, the command line tool, which was originally only available in Linux, but now is deployed as part of Windows. At this moment in time, it may need to be installed as an add-on feature, but I'm sure at some stage it'll be a core component on a deployment. When we do the installation, we need what we call the ISO file to do it. It's basically an image, a DVD image. That image is available from Ubuntu itself, or you can obtain it from the NAS drive in the laboratory. From Windows, you can get to that using the run command and typing in //nas3 or //nas3.offcampusnetwork.co.uk. Both of those links, or what we call universal naming conventions, what both of those will do is take you to the actual NAS drive. If you go into the modules folder and into KF5004, you will find the ISO file for this module. When it comes to the installation of Ubuntu, what we want to be doing is making sure that it will work with the environment we've got. Generally speaking, we will have keyboards that are UK English. That allows us to get the character set correct on the keyboard, so we need to check that. We'll be able to go with the default disk installation. However, when we're asked for machine names, what we'll do is, in this case, we can give it any name we want, but generally we give it a name that is sort of in line with the actual functionality of the server. You can set yours to your user ID, but once you start doing full deployments, it's actually easier to keep a name that is actually relevant to the function. So when you look at the key, at the actual command prompt, you actually know which machine you're on. The reason we're doing what we're doing here, using all the defaults and then moving on, is that we want to have a minimal installation of Ubuntu. We want no unnecessary packages and no graphical interface whatsoever. We're trying to avoid inadvertently adding in some kind of insecurity. When we've completed the installation, you'll be able to log into the machine at the console. Now, when I say console, what I mean by that is as though you were stood in front of the physical machine. Now, the way we're working at the moment, we're running VMware, so we have a window and we use that window. However, what we want to do is we want to actually simulate the way this would work in an industrial environment. So what we want to do is turn that machine into a headless machine and then connect to it. Now, it will be easier when you start working through the module just to use the console, because you can have multiple machines, you can select them, and you're not logging in and out that way. You just have them all running. However, I do want you to go through the process of building a machine as though it was going to be deployed into a server room. So let's get that machine set up and running. First of all, you open up VMware, and one of the options you will have is creating a new virtual machine. When you select that, it will allow you to select the ISO file. So in the case of this machine, from the desktop, I picked up the Focal Live ISO file. It automatically detects that it's a Ubuntu server 2004 for me. At that point, I can now move on. Now what I can do is I can specify usernames and passwords. However, we're installing a server, and VMware is more targeting the desktop environment. So although we put these details in here, we will have to re-enter them later on, but that's no big deal. So we put in our name is student, username student, Northumbria, Northumbria. At some stage, Canonical may make it that the server will actually have these details populated into it as part of the installation, which is why we should always put them in. Next, we give the machine a name. We can give it any name we want. It could be your user ID, or it could be the actual name of the functionality of the machine. Now, this is VMware. This isn't the actual operating system. This is the name that appears in the taskbar, not the taskbar, sorry, in the header bar on the window. So that's a great way of identifying what the machine is as well, just from looking at the title bars. Next, we should use the browse button and we should locate it. In my case, I would navigate through to my D drive, and I've got a directory called virtual machines, and I create a folder, and in there I've created a folder called DNS1 because I'm going to make this my first DNS machine. I select OK, and it will automatically offer me a 20 gig hard drive and offer to split the drive into multiple files. I'm quite happy with that, so I'll move on. However, what I'm not happy with is once I'm actually at this point, it's now trying to create the machine using the NAT network. And I don't want that. I don't want the NAT adapter. So I'm going to have to customize the hardware. I select customize, and then I can simply select the NAT adapter and then change that to bridged. If you notice, there's a little checkbox that says power on this virtual machine after creation. What we're at the point at now is we're now creating the virtual environment to run the operating system. We're creating the virtual machine, the hardware, simulated. When I click finish, what it will automatically do is actually start the installation process for Ubuntu. So we're now moving away from the VMware setup and moving into the Ubuntu setup. In our case, we pick our language, which will be English, and move on. Now, at this point, it will allow us to select the keyboard. We should select English UK because the keyboards we're using in the laboratory are UK keyboards. That's the only reason we need to select English UK. Once we've selected that, it will start moving towards now implementing the networking components, which we've set as bridged. Because we've set it as bridged, it's connected to our physical network, and it will use DHCP to get an address from our DHCP server. In the case of my network, it's picked up the address of 10.168.100.25. I move on from that. It asks me if I use a proxy on the network, which I don't. It now asks me if I want to use all the hard drive, which I do. We don't need to make any changes and repartition it. After all, this is a virtual machine, so there's a limit to what we really want to do with it. So we just leave that where it is, say use the hard drive, and go to done. It now gives me a breakdown and says this is what the drive is going to look like when I create it. That's what I want. I say done again, and now it starts the installation process. I select continue, and it will write those details to the virtual hard drive. In saying that, what it's actually doing is writing a partition table to a virtualized drive. Now it asks me to start putting in user details and machine name details, which we did right at the beginning, so we are having to do it again this time. So we give it a name, we'll call it student, we'll give the server a name, in this case I'll call it DNS1, and then we pick a name, student, password, Northumbria, and Northumbria again. So it's a basic, straightforward setup. After we've given those details, it now asks us if we want to start tailoring the server. Now remember what we said, when we actually set our machines up, we want total control of what we're doing. So we will not install anything at this stage. We just want a bare bones machine, so we can tailor it for whatever purpose we want. We select done, and again, it offers us more kinds of functionality that we might want. We don't want any of those, so we move on. It will now start the installation process and put all of the files onto the hard drive that it requires, and it will also download and install security updates. At this point, I can skip that process or I can leave it. If I leave it, it will come back and say that it's actually installed the system, copied all log files, and all the updates are now done. If I now select reboot, the virtual machine restarts and loads the operating system that's been installed. Because it's a first time installation, it goes through various updates and setups in the background, which we can't control. We have to let them run. And it will at a point seem as though it's actually stopped working. It hasn't. If we hit return key, we'll find that we actually do get the login prompt. If we log into the system, we'll find that it comes up with the machine name, as we can see at the bottom there, DNS1, and now we're in the machine and ready to use it. If I actually exit out of there, it goes back and it's as though we were sitting at the console of a machine. We can log in at this point again and start working on the machine if we wish to. So we've got the machine up and running, the installation's complete. However, one of the things we should always do with server machines on a regular basis is actually update them. Now there's two things that we need to go, two processes that we need to go through to do an update. One is we need to update the repository database. The repository database keeps a record of where all of the latest versions are stored on the internet. So we need to update that so when we do upgrades, the actual software can be found. We then do the upgrade and it will take the actual latest versions from those repositories, download them and install them. You should do this on a regular basis or ad hoc, depending on what the actual update requirements are. Security updates, you should really get those installed as soon as possible. Generally speaking though, in a production environment, you wouldn't update your live machines. You would generally test updates on a test bed, and then when you're comfortable that they work correctly and don't interfere with any of the software you've already got installed, you would then run them. But for the purposes of this module, we can just get the updates done. This isn't a production environment. Once you've got all the software updated and the machine sat ready, basically what we've now got is a bare bones machine. We can only access it from the console and that's it. What we need to do now is create the remote access facilities. And there's two ways we can do that. One of them using SSH and the other, which I'd like you to have a look at as well, is using Telnet. Now, SSH is very, very secure and we'll be looking at that in a bit more detail in another module. But Telnet is very insecure. So one of the things we'd like to do is actually have a look to see why it is insecure, and we'll do that in the workshop. Before we can even remotely connect to these machines, we've got, say, the SSH server running and the Telnet server running, but how do we actually remotely connect to that machine? We need to know its IP address. When we're logged in, we can get the IP address very easily simply by typing in IP space A and hitting return. And what it will do is it will give us the IP details of all of the adapters. So in the case of this machine, LO, the loopback adapter, 127.0.0.1, and also ENS33. And that gives us several addresses, some IP6 addresses and an IP4 address, 10.168.100.25. And we saw that actually in the installation when it came up and said it was using DHCP. So it's actually maintained that address. So if that machine's sat now running and we want to remotely connect to it, what do? If we run PuTTY from our machine, we'll use PuTTY in this case, all we have to do is simply in the IP address is type the address and then select port 22. In fact, we don't even need to do that because by default it shows up that it wants to use SSH. It's that common for it to be used. So all we have to do is put in the IP address and select open, and that will initiate the connection. Now, when you connect to an SSH server, the first time you do it, the machine will send you a security alert, or you get a security alert within PuTTY anyway. When you accept that key, you'll then get a login prompt. And from here, we simply log in with that same account that we created right at the beginning, student Northumbria. So we'd log in with a student, password Northumbria, and we're logged in. And as you can see, the prompt, DNS1, student. But we're now logged in using a piece of software, and that machine could be located anywhere. So we're now connecting to that machine as though it was a headless server. When we're actually logged in, we can actually see that connection on the server. If we type in the command ps, which lists all of the actual processes, -ef, it limits the format, and we pipe that through grep, which is a text processing filter, and then we specify a piece of text, in this case SSHD. What it will do is it will list all the processes which have SSHD within the text. In the case of this, we have 4 that have came up. 2 of them are linked to root, But one of them, if you know, the other two, sorry, you'll notice are linked to student. And the third one down, you'll notice it says student at PTS/0. That is the pseudo terminal. That is the actual PuTTY connection to the server. Now, once we're connected, we might want to start doing some connectivity testing. We may be able to connect to this machine, but can't connect anywhere else. And there's various tests we can do just from our basic setups to actually make sure that they're working as we expect. So the first one of those would be to say install traceroute. Now, sometimes traceroute is installed by other packages, but if it isn't, we simply install it with sudo apt install traceroute. And what traceroute allows us to do is track the traffic from our machine to the destination. So that's actually testing quite a few things for us. If we use a URL, it's going to test the DNS server to make sure that's set up, or what we're linking to is working correctly, and it will check that the gateway is set up correctly for us to get from where we are to the destination. So it does quite a few tests in just that one command. If we have a look at it, run against Google, you'll see that it comes up and says it's connected to 1, 2, 3, 4, 5, 6, 7, 8, 9 different machines to get there. But it got there. So that means, first of all, because it says www.google.com, the DNS must have worked because it got a destination IP. And from then on, we can see that it's actually being able to get the traffic to go across the network. So that means the connectivity is working perfectly well for that machine. Now, at the moment, this machine is set up using DHCP. Now, servers, generally speaking, internet servers are generally fixed in terms of their IP address on a network. The reason for this is that we try to limit the dependency of one service on another service. If one of the services went down, this service wouldn't go down because of the DHCP update. So generally speaking, any servers that we put on networks will have an IP address rather than a DHCP allocated address. They'll have a static. If you want to have a look to see how that works, have a look at your configuration on your machines, your Windows machines or your Linux machines, and you'll generally see that all of the settings are set as IP addresses rather than names. And that's because we're trying to reduce the dependency, the interdependency of network services. Okay, so we need to static the IP address on this machine. So how do we do it? Well, first of all, most network services or any kinds of services on a Linux box are normally configured through a text file. Once we edit that text file, we have to reload the service and it reloads the configuration. And that's exactly how it works for the static networking. We can use any editor we want. Now, this module is not about any particular editor. This is all about configuring operating systems, so you can use whichever editor you're comfortable with. Personally, I use Nano. It's nice and simple to use. It's full screen. You can navigate with the arrow keys, and there's a small menu at the bottom that helps you or sort of guides you as to what you need to do within the editor to get the functionality you want, loading files, saving files, searching for things, etc. So I tend to use Nano. You can use whatever you like. Now, when it comes to editing the actual configurations, since 1804, and it's the same in 2004, which is great, the networking component is something called Network D, and that uses an application called NetPlan. The configuration files for this are actually in etc netplan, and we simply have a single file, could be multiple files, but a single file for our purposes, and we can edit that file to make all of the changes. Now, historically, there was a system called Network Manager. Now, if NetPlan is disabled, it reverts back to that, but we're going to use NetPlan, but be aware that there are alternatives. NetPlan files are actually in YAML format. So if you want any information on what YAML looks like, you go to yaml.org and there's a load of information on there. It's basically structured text. For our purposes though, we're only using a limited amount of it, so we don't need to worry about the full specification. We just follow this as to how we structure it for this file specifically, and we should be fine. Now, when it comes to the configuration file, in the folder etc netplan, you will find a file called 00 installer config.yaml. Now that's as far as the current installation goes. I have seen this change over time where you do an update and no longer is that the default file on the installation. So at the moment it's installer config YAML. So whenever you do an install, a fresh install, always make sure you check that file to see what it's currently been changed to. The default file created at install looks like this. As you can see, it says network followed by a 2-space indent Ethernets followed by a 2-space indent ENS33. This is the YAML format. Each section is indented. If any of you have done any Python programming, it's a similar idea. Indents indicate blocks. So in this case, at the top level, network, that is everything is then encapsulated inside there. Then we have the Ethernet cards and we have a list of them. So in this case, there's only one. And if you remember, by default, we installed DHCP. So DHCP4 is set to true. So all of the networking details are implemented through that. At the very bottom there, we see it says version 2. That is the version of the format of this file. What I tend to do is restructure this slightly because where things are in the same indented level, they can be resequenced. So I tend to put version 2 at the top. So the last section I have is all of the Ethernet configurations. Whenever we make any changes to this file, we must execute the command sudo netplan apply, and that will actually action those changes. So inside my new version, which I've created for the static IP, you'll notice there's quite a few changes. First of all, I've moved version 2 at the top. I just prefer it there, it's easier. Renderer, network D, and then I have all the Ethernet cards below it. And because I've now gone to a static IP, there's quite a bit more information in there. First of all, I have to disable DHCP4. If I don't disable it, my machine will end up with 2 IP addresses. One, the one I statically address, and also a dynamically allocated address. Next, underneath that, the next directive we have is addresses. And in here, we can specify the actual IP address. However, it does 2 things in here. We have to give it the IP address we want and also the subnet mask. So in this example, 192.168.1.2 is the IP address and it's on a /24 network, which means the base network address on this machine is 192.168.1. Underneath that, because I'm using IP4, I specify the IP4 gateway. In this case, 192.168.1.1. The one thing I don't have at the moment is my DNS settings, my name servers. So the next option is name servers. Now this has multiple entries for it. So below that, we specify the addresses, and in the square brackets, we can specify a list that we want. In this case, I've specified 2 name servers, and that's both the Google servers, 8888 and 8844. Once I've made those changes, as I say, you just use netplan apply, and that will be immediately implemented. Bear in mind, if you're doing this through a remote connection, you've just changed the network connection configuration. So you will lose your remote connection. Not only can we use IP4 in this file, we can use IP6 as well. And here's a simple example. Notice I've disabled the DHCP6, added in an IP6 to the addresses, added a gateway 6, but I've left my name servers. We'll discuss that later in the module when we look at how DNS works, because DNS can give out addresses for either IP4 or IP6 from an IP4 or IP6 DNS server. If we wanted to actually disable netplan altogether, all we would do is change the renderer from being network D to network manager. However, this is just in case you come across machines that are doing this and you want to revert it back to netplan. Our module is only going to be using netplan, nothing else. As I said, don't forget, any changes you make, you must reapply them with netplan apply. So now we want to start looking at some of the other things we can do with the network. We've got our machine statically addressed, we can use it now. We can remotely log in and we could get going. But we may have problems, or we may find there are issues. We may have multiple network cards, whatever it may be. We just need to know a little bit more about what we can do with the card, with the networking, sorry. So First of all, if we want to disable an interface, let's say we had two, we can use the IP command and we can set the link to down. If we then want the link back again, we can re-enable the link. So we've got control of the network cards. If, once we're up and running, we want to check and find out what the IP addresses are, we've already seen a little bit of this one, IPA, and that gives us the IP addresses of all the, it gives us all the IP addresses connected to all of the network cards. If we're only interested in IP4, the -4 option. If we're only interested in IP6, we can use the -6 option. Likewise, if we want to see where the routing tables on the machine are set, we just simply say IP route. If we want to know what the routing tables are for IP4 only, -4 route. Interestingly, IP -4 route is very useful because that allows us to make sure that the gateway details are set up correctly. When it comes to doing connectivity testing, one of the commands we will very often use is ping. However, something you need to be aware of is that ICMP is sometimes blocked. So although ping will generally work in a local network, when we start going to wide area networks or routed networks, we can have problems with ping not working. However, for our purposes, it's quite usable because we're going to be only having a few machines on our network. So we can quite happily use ping to do some testing. In the laboratory, this will work across all three of the labs. So ping -C5 means send 5 ping packets to a specific address and we get a response. If we get the response, we know that we've got the machine correctly addressed. We know that because it means we've got the IP address on the right network and we're able to get a response from a server. Sometimes we may want to do even more detailed controlling of the network. And there is a tool called ethtool. Bear in mind this can sometimes be installed with other packages, but if it's not installed, you simply install ethtool, and then you can do some quite detailed analysis of the network card. Now, we probably won't use this tool in the module, but it's something that's worth knowing about. ethtool will allow us to look at what the driver is capable of doing. In other words, what the card can do as well. So the speeds it can run at, you can change speeds, etc. So a simple command, ethtool ENS003 in our case for our network card, and we will be able to have a look and see what details we have with respect to the drivers. We can also do tests with our DNS to see that they're working. So in this case here, if I run the NS lookup tool, I can look up a URL. If NS lookup is not found on the machine, you can simply install it because it's a part of DNS utils, or it may have been installed as part of another package. But if it's not there when you type in NS lookup, you can install it. It allows us to do a lot of testing of the DNS architecture, and we'll be using this tool quite a bit later in the module. So you may as well get it installed now and have a little play with it. So a simple use of it would be to say do an NS lookup on, say, netflix.com, and it will go off and it will run the actual query and it'll come back giving us the IP addresses, or in this case, multiple IP addresses, which is something we'll actually be discussing later in the module as well. So what have we actually found out from doing this installation? Well, we now know how to install Ubuntu Server. On top of that, we know how to set up VMware to support Ubuntu Server. We know what headless mode is now. Basically, no keyboard, no monitor, and your machine's actually in a rack somewhere. We know how to access it because we know what applications we need to install, and we also now know how to static the IP address of our server. This gets us to the point now where we can actually start looking at our network services. So from this point on, we're now going to be looking more into how DNS works, how web works, how the file systems work, and also how the database can be tied into all of that to create the architecture that we need.